counter going?
Yes.
Yes, alright. So, today, where are my notes last time? Alrighty, so we are going to basically review, and I have done what I said I would, and I have got a 3x5 right here. Here is the front of my 3x5. Right there, that's the front of my 3x5. And here is the back of my 3x5, not overly long, but that's mainly because there are so many of the same kind of question. Okay, so before we get started, I do have a couple of questions that I have been asked to look at off of the homework, so I want to pull them up first. So it is 4:13. This is Chem 11:10, Chapter 12, Review. Alrighty, so let's see. Here we go. Here's the first one. So I don't know. So it says, draw the structure corresponding. So this is going backwards. Now there are two of these, I think, on the test. So it wants 3,3 dash dimethyl pentane. So what I do, anytime I'm going to work backwards, I start with my backbone. My backbone is always going to be the last word. So this is going to be a pentane. So I'm going to basically draw how many lines? 5 lines?
4.
4 lines. Which is it? So if I go 2, 3, like that, is that a pentane molecule?
Yeah.
Yeah, because the end counts, right? So it's 1, 2, 3, 4, 5. That's my pentane. Now, this is 3,3 dash dimethyl. So, di means I've got how many of them? 2 of them, which has to match, signifies I've got 2 numbers. These are both coming off the third one. So it would go 1, 2, 3, 4, 5. So right here I would have, and it doesn't matter how you draw this, but I could draw 1 there and 1 there, right? Now why do I only have 1 line?
Because it's a methyl.
Because it's a methyl, and a methyl signifies that it is only 1 carbon, right? And there's a carbon there, and there's a carbon there, right? So I've got 3, 3, except they're both coming off the third carbon, so I've got 3, 3 dimethyl pentane. Okay? Now the next one is 3-ethyl 4-methyl, and then this is hexane. Okay, so now I'm still going to start at the end, so I'm going to start with a hexane molecule. So that means I'm going to have how many lines? Now I'm going to have 5 lines, because 5 lines gives me what? 6 carbons. So I got 1, 2, 3, 4, 5. So that's my hexane. 1, 2, 3, 4, 5, 6. There's my hexane backbone. Now, I'm going to go to my third carbon, and I'm going to draw an ethyl group. Now, an ethyl now has how many carbons?
2.
Yeah, an ethyl's got 2 C's, whereas a methyl only has 1 C. So here I'm going to draw 1, 2, right? And that's my ethyl group. Now I'm going to go to my fourth, and I'm going to draw a methyl, which would be something like that. And that would be 3-ethyl 3-ethyl-4-methyl-hexane. Does that make sense?
Yeah.
Yeah? Okay, that was one of them. Let's see the other one. Okay, and then here's the other one. The other one was this one. And I've had this question multiple times. Anybody know the one I'm talking about?
Oh yeah, I got that one.
Okay, I've had this in multiple times. So this is what I would do. Let's just pick one out here. Let's say I did this one. Okay? So this is what they give you. They give you CH3 taken twice, then I got CH2, CH3 taken twice. Now, a lot of the battle here is being able to go from the condensed version to the skeleton version, in my opinion. Okay? So, what I do is, I know I've got 2 CH3s bonded to that carbon, right? So, I've got this carbon, and I'm going to go like this. So let's say I do it like this. I got this carbon, I've got that carbon, I've got that carbon. So I got that, and I got that. That is one of those, that is the other one of those. This one is this carbon right there. Okay? And then that carbon is bonded to an H there, and then it's bonded to another C, right? And that C is bonded to an H there and an H there, and it's bonded to another C, right? Then that C is bonded to an H, but then it's bonded like this to a C and a C. Running out of room, dang it. And then these all had H's around it. So it's going to look something like that. So what I would do then is from here, then I would go and draw the skeleton. Well, I've got 1, 2, 3, 4, 5. 1, 2, 3, 4, 5 carbons, right? And then I've got this one would be that one, and then that one would be that one. And I now have 1, 2, 3, 4, 5, 6, 7 carbons. 1, 2, 3, 4, 5, 6, 7 carbons. Now, wants me to name that, right? So, once I've got it like this, to me it makes it easier to name. So then I've got, so we're down here. Let me zoom out on this again. So this has 1, 2, 3 boxes, right? So it's got 3 boxes. Alrighty, so in the first box is going to be my numbers. Well, where are those branches going to happen at?
2, 4.
So I got 2, 4, right? Okay, and then my next thing is going to be what? What are each one of these? How many carbons are in each one of those branches? 1. So that makes it a what?
Dimethyl.
Dimethyl. So I got dimethyl. And then my backbone is what?
Pentane.
Pentane. Like that. But do you see how this is way easier to do this to than either of those are?
Yeah.
That's why I like to take the condensed, turn it into a Lewis, and then from the Lewis, I like to turn it into a skeletal. Now, that's a lot of work to get to this. If you can do that from either of these, I would say do that. If you can't, I would try to get to that and then go from there. Does that make sense or no?
Yeah.
Okay. Did the person that emailed me that question, I don't remember who it was, does that make sense?
Yeah.
Okay. Alrighty, so from there, I had somebody else email me it, but I couldn't find the email. There was one more question. Anybody else email me? I had one more, but I can't find the question in my email. I don't know if I deleted it or what. Aaron.
You about isopentane, isobutane.
Okay, yes. Now, was that you, Aaron?
Yeah.
Did what I replied back make sense?
You just said you would draw it for me.
Okay, now, I want everybody to understand this. Anytime, well, let me preface this. Have I taught this before today? I did talk about one thing one day, and I believe that was isopropane, wasn't it? Anybody remember me talking about that? Nobody? Okay, well...
I think I remember it a little bit.
Okay, I vaguely mentioned it. Now, understand, if you go back to anything I've taught prior, if I haven't taught it by today, well, what's probably a good safe bet? Okay, but, so you can do the homework, I'm going to show you something. When they use the term ISO, you need to think, not thing, sorry, that's a K. You need to think why. So if I had like isobutane, it's going to look like this.
Oh, isn't that splitting on the second?
1, 2, 3, 4. It's going to split like that, right? So if I had isopentane, do you see how that kind of makes a Y, Aaron? When I said think Y on that? Yeah, that makes sense. They're always going to make a Y on the end of them. So if I use that as a branch, just go wherever that is and draw that kind of branch in.
Isn't it like in a different chain though? Like it's not all in the same continuous chain?
What do you mean?
Like when we're doing the backbone, when you're naming it, like pentane or whatever, you only like go for the longest chain.
Yeah, so these would always be a branch. And you're right, you have to be really careful. So like, if I were to use isopentane, I would have to have a really long backbone, or that could be my backbone. You're right. So like, I couldn't do this. Like, let's say I gave you this. Let's say I gave you hexane, right? I couldn't have, like, 2 isopentane. I couldn't. Because now, that isopentane actually becomes my what? Do you see how that makes me a longer backbone?
Yeah.
Yeah, so anytime they use these kind of branches, you're going to have a really long backbone and they're going to come off of somewhere in the middle, or it does screw you up bad. Does that make sense?
Yeah, that does.
Yeah, so usually they'll have like an isopropyl or something. Like if I did this, here's a good example. So I got 1, 2, 3, 4, 5, 6, 7, 8. Now here, I could do this. I could do like that, right? So now, because I've got that, this would be what's called 4-isopropyl octane. Because now that doesn't give me a longer backbone. Do you see what I'm saying?
Wouldn't that be isobutane?
No, because remember, there's only 1, 2, 3 carbons there. It's branched off the middle one, so it still makes a what? Still gives me that Y look. That carbon doesn't count, remember, because that's part of my backbone.
Yeah, I see.
Okay. Does that kind of answer that question now, Aaron?
Yeah, that does.
Okay.
Thanks.
Anybody else? Nobody? Alright, so here we go. I'm just gonna start. I already showed you my 3x5, right? There's the front of my 3x5. Here is the back of my 3x5. I'm gonna go through this, and then did you guys like what I did last time and stayed on a little bit at the end? If you want, I can do that again today. I think that gives us a good idea to do some communication, but whatever, okay? So, you need to make sure you understand an alkane from an alkene. Okay, to be an ene, what does it have to have? Anybody remember?
Double bond.
At least one double bond, right? So an alkane is going to be CXH. Anybody remember the little formula I gave here?
14.
2x plus 2.
2x plus 2, right? And an alkene is CXH what?
2x.
2x. Now,
And
what?
that also works with the cycle.
Exactly. This is the same for cyclic structures. I was literally just going to mention that. Good job, Tolman. Okay? Now, as I went through the test again this morning, there are 3 things that if you can do, you ought to be able to get at least 50 on this test. And that's only 3 things, okay? You've got to know what a constitutional isomer is. Constitutional isomer. Okay, you've got to know what that is and how to do it. Okay, and then you've got to be able to do the IUPAC names. IUPAC names. And then you've got to be able to classify C's. Okay? Now, classifying C's to me is the easiest. That is simply one of 4. What are they going to be?
Primary, secondary.
Primary, secondary, tertiary, quaternary.
Primary, secondary, tertiary, and quaternary. There's like 6 or 7 of those, maybe 8 even. Okay, that to me is the easiest kind of question you're going to run into. Okay? Now, IUPAC names, that's something we've spent probably more time, wouldn't you say more time than anything else? Right? Is there anything else we spent more time on than naming compounds?
No.
No. Okay? And then who remembers what a constitutional isomer was?
Works the same, like, compounds, but they're arranged differently.
Yep. Same formula, arranged differently. Now, they ask you this question like 7 different ways, people. Ultimately, what I would do is this. So, let me... I thought I wrote this down. I did not write it down. But let me go and find one. Let me go and find a really good one. Didn't we do a few of these last time? Anybody remember? Didn't we do a couple of these last time?
We did.
Okay.
Yeah.
So here's an example, and I don't. Gosh, dang it. Let me look. I don't want to duplicate anything that I did last time, because that's a waste of time. Let me see if I've got a constitutional isomer. I think the best example, I did last time, but I don't see it here. Okay, so maybe not. So this is what they give you. Okay? So the best example out of the book is this question right here. It goes CH3, C, does that, and it does this. It does that. And it simply says, are these constitutional isomers of each other? And all I would do is I would write down its formula, and see if they are the same. That's all you got to do. So what's this one's formula? And usually it goes C's, H's, and O's.
C3H6O2.
X02.
What about this one?
Same.
Same, C3H6O2. Now, what is the only thing, and this is really important, there is one caveat you've got to make sure.
That's not the same molecule.
Make sure they are not identical. So I did mention this the other day. Make sure they're not identical. That's the biggest thing I noticed on the test. So on the test, what they did is something like this, except they gave you this, and then they said, which of the following are constitutional isomers? And then they give you like 4 to choose from, right? And they'll give you like 1 molecule, or they'll give you like 3 molecules, and then one of them might say more than one answer. So make sure you do all of them, so you can kind of look through them. But the key is making sure they're not an identical molecule. So look at it frontwards, but also look at it what? Look at it backwards, because remember, sometimes we number from the right. Correct? So make sure I look at it and they're not identical, because if they're identical, then they're not constitutional isomers, they're the same compound. Okay? That is the hardest kind of thing, or this is the hardest kind of thing I thought on the test, is when they gave you some that were identical. That makes sense?
Yes.
Alrighty. Now, next thing I want to do is, I'm going to give you this. I'm going to give you 2,2 dash dimethylpentane. Okay? Now, what they do is, remember how I said most of them, they give you the formula and they want you to name it? Right? The IUPAC stuff I was talking about? Well, there are a couple, and I don't remember if this was Allison's question or not, but somebody asked me about when they give you the name and they want you to draw it, right? Now, what I would do is if they give me the name and they want me to draw it, they could have me draw it one of 3 ways, right? They could have me draw it how? What are the 3 ways they could ask me to draw it? They could ask me to... Say that again?
Skeletal, complete, or condensed.
Yeah, skeletal, complete, or condensed, right? So what I would do is I would probably go to the easiest one first, and to me that's a skeletal. So I'm going to start with the what? Where do I always start when I'm going backwards? The backbone. And the backbone is always going to be where? The last word. So this is a pentane. So you got 1, 2, 3, 4. 1, 2, 3, 4. I got my pentane backbone, right? Now, it doesn't matter whether I number it left to right or right to left. Let's just go this way just for kicks and giggles. 1, 2, 3, 4, 5, right? Now, branching off my 2, I've got to have a what? What do I got to have right here? Dimethyl. So I'm going to have just 2 what? Yes, I'm just going to go right there and right there, right? That's going to be my dimethyl, correct? Now, here's my question. What if they gave it to me, what if all my answers, though, are in condensed form? Can I go from there to there? That's the question. So this is what I would do. What would this be if I were to just write it in C's and H's?
CH3.
So I got CH3. What's this one going to be?
CH2.
What's this one going to be?
CH2.
Okay. What's that going to be?
Just the C.
Just a C. And then I've got 1, 2, 3 CH3s like that. Now, does anybody know how else I could write that and have it be the exact same thing.
Reverse order.
Yeah, I could have went CH3, 3, C, CH2, CH2, CH3. When I say reverse order, remember C always comes first in that type of situation. These are the same thing. And that's, I mean, I think we can do this. This, I think, is a little more challenging, which is why come Wednesday, make sure that you're on right at 10 so that you have as much time as you can use to do in case there's only like 2 of these, I think, but, you know, I want to have as much time to do those as we can. Okay?
Couldn't you also combine the CH2?
Now, what I have noticed, Sierra, that's a great question, is it's weird how they do a couple of these, because it's like they're saying, well, let's condense, because what they'll call it is they'll call it condensed, and then they'll call it, oh crap. It's like a complete condensed or something. You don't see it very often where they'll like condense all of these. You just don't see that very much, but you're right. They could have went CH3 taken 3, and then C, then they could have went CH2 taken twice, and then CH3. What I've noticed though is they just don't do this very often, but you're right, they could have. But I would not, this would be the last thing I worried about, okay? That makes sense?
Yeah.
Alrighty, now, I talked about this the other day, but if I want to have a low boiling point, okay, what kind of compounds did I say had a low boiling point, or by the same thing, it could be low what? If I go low boiling, it could be low boiling or what?
Melting.
Low boiling or melting here. What did I say gave me a low boiling or a low melting point?
Wasn't that small surface area?
Okay, so small surface area, but how did you know that? Say that again?
It had branches?
Yeah, small surface area equated to more branches. Which means that if I have a straight chain versus a branch chain, the branch one is going to have a lower boiling point than the straight one. Okay, what was the other one?
Less C's.
Yeah, fewer C's. Fewer C's. So if they're going to compare 2 of them, like they give you 2 compounds and they say which one has the lowest boiling point, it's going to be the one with the fewest amount of C's, or the one with the smallest surface area, which gives me the most branches. So it's something like this. Let's say I did this. Let's say I did those 2, right? And I said, which one has the higher, well, let's not do melting. Let's do, most of these are boiling because most of these are already liquids. Let's go the higher, which one would have the higher boiling point? Because they both have how many carbons? Nobody?
5.
They both have 5 C's. Okay, so I can't do this one because they both have 5 C's, right? So I got to go back to small surface area, more branches is low boiling point. Well, clearly this one has way more branches than that one does, right?
Mm-hmm.
So this one would have I asked that question backwards. What would the answer actually be?
The other one.
The other one, right? Sorry. Up all my freaking white out. Because I asked for the higher one, that would be that one. Does that make sense?
Yeah, but what if this one had like less surface area?
Okay, so
Had
let's
more surface area, less C's?
Just a minute, I got a text from the secretary. I'm supposed to be in a faculty meeting right now, but they just decided to have the faculty meeting right when we'd already arranged to teach, and I felt I owed it to you guys, so sorry. Well, not sorry to you, sorry to Mrs. Perry. Does that make sense? Hello?
Mm-hmm.
Yeah? We're good there? Alrighty, so next thing I've got is pure hydrocarbons. Pure hydrocarbons do not hydrogen bond. Anybody know why that is? Why pure hydrocarbons do not... Oh my hell, I can't write this morning. Anybody know why pure hydrocarbons do not hydrogen bond?
The hydrogen has to bond to an S, O, or N.
Yeah, there are no F, O, or N's, right? Because in a pure hydrocarbon, it's only what?
Hydrogen, carbon?
Yeah, just H's and C, so I don't have any F, O, or N's to bond to. Okay? Alright, now, there is like 3 questions on what are known as alkyl halides. Anybody remember what an alkyl halide was?
It's a carbon-hydrogen chain with the halogen at the end.
Okay, so it's going to be either a what? What were the ones I said we saw the most? Do you remember?
Like fluorine.
Yeah, fluorine, chlorine, and bromine are the 2 you're going to see. So what happens, and this is I actually wrote this down. This is on page 446 and 447. I want to say, I think there's 2 to 3 of these. Okay, let me just kind of give you an example of what they did. Okay, so, what they've got is this. It doesn't matter what it is, but if I were to take, like, let's say I took a cyclopentane here, okay, and I add Br2 to it. All that's going to happen, that's not an equal, this should be a yield sign, is, anybody remember what I taught you was going to happen here? Nobody?
They're going to swap.
Okay, yeah, so one of these is going to merely take place of one of these H's. So right now, each one of these has a whole bunch of H's, right? I got H, H, these are all H's, right? Right now, that's what that looks like, right? What's going to happen is the Br, because Br2 looks like that, this is going to break, and one of them is going to go on where one of these H's are, and one of those H's is going to go there. And so I would end up with this. It's going to look something like that. And it doesn't matter whether that's Br or Cl or F, they're all going to behave the same way. Okay? And it doesn't matter where, it's going to go where any one of those H's are. It's just going to be plugged into that. And that creates now an alkyl halide because it bonds to a halogen, which is where the halide comes from. Does that make sense? I got 0 feedback there, people. Does that make sense or no?
Another one?
What?
Will you do another one?
Yeah, so let's say I gave you, let's say I did this plus Cl2. Okay? And right now, I've got all these H's, right? I got that, correct? Does that make sense? Now, typically, it's going to go on, and I believe it was Sierra that mentioned this, they typically go on the what? Was that you, Sierra?
Yeah, it was. It's typically at the end.
Yeah, they typically go on the end, so this CL is just going to go to one of these, wherever, it doesn't matter. So I would have this, and then I would just have this plus HCl like that. And the rest of these would all just be, nothing else changes. It would look something like that. Does that make sense, Allison?
Oh, yeah.
Okay. Alrighty. Alrighty, so number 36. Alright, I'm gonna do 1, 2. Alrighty, so Aaron Haas still on here?
Yeah, I'm on here.
Alrighty, so this is kind of along those lines of that question we had earlier about how that branch might actually be the backbone. If I were to draw this 1,4-diethylheptane, I'm going to start with a heptane, which means I'm going to start with a 7-carbon chain, right? So I've got that, correct? That's my heptane backbone, right? And then I'm going to have 1,4. So I got 1, 2, 3, 4, 5, 6, 7. So at 1, I've got an ethyl, right? So if I go here and I draw an ethyl in, what have I done there?
Extended the chain.
I've extended the backbone. So could this even exist as 1,4-diethylheptane? No. Okay, so this does not exist. Okay? Now, what I'm trying to illustrate here is there are a couple of questions where they'll give you something and say, does this name constitute an IUPAC name or something? And you're going to look at it and say, well, yeah, it reads like one would. But once I draw it, I realize that doesn't exist. Because 1,4-diethylheptane, if I were to truly name it correctly, would actually be something else. Does that make sense? So when in doubt, draw these suckers up and make sure they are a real name and that it's not jacked up. Do you guys see what I'm saying there?
Yeah.
I'm trying to show you this without giving away the questions. But it's going to look something like this. They're going to give you something and say, is this a legitimate IUPAC name? And just to look at it, I'm like, yeah, that looks good. But when I draw it, I realize, no, that doesn't work. Okay? So make sure you actually look at them. Okay? Alrighty, so this is what I have written down next. Oh, okay. Now, I want you to draw. No. Okay, this is what I want to go from skeleton to condensed. So if I drew this, if I gave you that, this is skeleton, can you condense that for me? Can you go from there to the condensed form of that? Actually, let's do this. Let's do this. Give me Count up to 5. Let's go raisey handy. I want you to condense that for me. Write it. You guys understand what I mean when I say condensed, right?
Yeah.
Yeah.
Okay, condense that for me. Give me a count to 5 that's condensed.
1,
2, Am I 3 or 4?
You do 3.
Okay, I'm 3.
4, 5.
When you're 4 and 5. Alright.
8.
9.
Oh, good.
10.
Alright, so, who was 4?
That was me.
Okay, what do you got for me?
CH3 in parentheses taken by 6, and CH2, CH3.
Does that work?
Yes.
Yeah, so that C right here is that C, right? And then I got my 2 CH3s attached to it. Then I got that CH2 is that CH2, that CH2 is that CH2, and that's that CH3. Okay? Just making sure we're there. Okay? And then, alright, and then I have this written down, but I got to go to a new sheet of paper. And this kind of harkens back to what we just talked about, and I wrote this. My question says, if 6-ethyl 3-methyl hexane valid. Is that a valid IUPAC name? So again, I still think the easiest thing to do would be to do what to that? Draw it, right? So I know I'm going to start with the hexane, so I'm going to have how many carbons in my backbone? I've got 1, 2, 3, 4, 5, 6. Okay, then what am I going to do?
Branch.
I'm going to branch. So at carbon 6, so I would go 1, 2, 3, 4, 5, 6. At carbon 6, I'm going to draw an ethyl group, which could be like that, right? An ethyl group. At my 3, I'm going to draw a methyl group. Is that valid?
No.
No, because I just changed the backbone, right? So the answer to that would be no. Does that make sense?
So basically, if there's just like a 1 or a 6 in it, it doesn't work, right?
Yeah, I can't number it a 1 or a 6. Can't be done. But some of the others could even be a little iffy. Like let me give you a good example of this. Let's say I went 3-butyl dash 4, 5 dash dimethyl heptane. Okay, let's say I did that. Okay, so heptane gives me how many carbon backbone? What's hept?
7.
7. So I got 1, 2. So 1, 2, 3, 4, 5, 6. Right. So I got 1, 2, 3, 4, 5, 6, 7. Right. Off my 3rd, I'm going to draw a butyl, which means a butyl has what now? How many carbons does butyl have? How many?
4.
4. So I got 1, 2, 3, 4, right? On 4, I've got a methyl. On 5, I've got a methyl, right? So would that work?
Yes, because it's the same both ways.
Sure about that?
No.
Definitely not.
No, the butyl extends the chain by one.
Yeah, butyl makes me one bigger, doesn't it?
Yeah.
So by adding that butyl on there, I would have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? So now I'm a no-name, but let's see. That would branch me at 5, 6, 7. If I went this way, where would that branch me? Would that branch me at 3, 4, 5? Wouldn't that be a lower sum than 5, 6, 7? Correct?
Yeah.
Yeah, so this would actually be 3, 4 dash dimethyl. No, wouldn't even be that. It would actually be what? Where would I have to start?
That's the purple.
At the ethyl, it would be 5 dash ethyl, right? Dash 3, 4 dash dimethyl. Then that would be no name, like that. So you just got to make sure you're careful, which is why I want to make sure everybody's on at 10 o'clock on Wednesday. Okay? So you can have as much, you can have that full 2 hours to make sure of this. Okay? So that's what I've got. So let me go back over. So that is my 3x5. That's the front side of my 3x5. That is the back side of my 3x5. And if you're done, you're done. So understand this. So let me kind of make sure we've got everything done. So test. Okay, remember, the only time you will be able to take the test is Wednesday, 4/15 of 2020 from 10 a.m. to 12 p.m. just like last time. Do we all understand the words coming out of my mouth?
Yeah.
Yeah.
Okay. So then we will do a final pre-test review at 9 a.m. on 4/15. Just like we did last time. I thought, do you guys think that helped?
Yeah.
Yeah? So we'll do that final pre-test review. Okay? So that means all homework is due by what does that make it? What's that make it? 11:59 on 4/14, right? Okay? Alrighty, those of you that are good, take off. If there's anybody that wants to stick around and ask some questions, feel free. I'll give you about another 10 or 15 minutes if you want. Okay?
Can you answer those questions I sent you?
When did you send me questions?
Yesterday, the 3 that I sent you from 12A.
Oh, that's who it was. Is this Shuri?
Yeah.
Okay, let me see if I can pull them up. Anybody else got a question for me? Okay.
Just on the surface area versus carbon chain, does one take precedence, like if you have a smaller surface area but more carbon?
Okay, they will not, is that you, Karen?
Yes.
Okay, there is not one where they combine the two.
Okay.
Because, yeah, then you've got to learn that there are a few other rules there that if we were in, like, organic, I would get into, but not necessarily right now. Okay, so it's going to be one, they're going to use it one way or the other way. Does that make sense?
Yeah.
Okay.
Thank you.
Okay, anybody else? Alrighty, so Yuri asked me, let's see, let me pull my email up. Do you remember what day you sent them, Yuri?
I just texted them to you yesterday.
Oh, that's why, because that was a text, okay. Alrighty, so answer the following question about the alkane drawn below. Oh, okay, so this goes back to understand something. And this is, again, what I talked about with Aaron earlier. There are no complete, incomplete combustion questions on the test. Okay? Which is why I didn't teach any of that stuff. So, complete combustion always yields CO2 plus H2O. Always. Incomplete combustion yields CO plus H2O. So as I look at your thing, when you did this right here,
Yeah.
okay, that can't be C4H10. There's like 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There's 11 carbons in there, isn't there?
Yeah.
Yeah, it's this part that's wrong. The complete combustion's correct.
But what do I write in the reactant then? Like, you have CO2 plus H2O. What?
No, just what you did. This is right.
Okay.
Where did you get C4H10 from?
That's just what I looked up. We didn't know.
Oh yeah, no, it's this hydrocarbon. That's going to be C1, 2, 3, 4, 5, 6, 7, 8, 9. That will be C11, H, and then do the math. Does that make sense?
Okay.
Yeah, you have the right formula down. Yeah. This has to be whatever that is.
In the product, it's going to be
Yes.
okay.
Yep.
Okay.
And I believe Aaron. Did Aaron leave? Aaron Haas? Okay.
Yeah, you only have 22 people with you.
Oh, okay. Most people left. That's fine. It is what it is. But does that make sense now, Yuri?
Yeah, thank you.
And I believe that's all of them, isn't it?
That one, and then there's another one that's not. It's on solubility. That one.
So, predict the solubility in water. Okay, so this is actually a really good question. So, as I look at that, to be able to be soluble in water, what two things did I teach you to look for? Polarity and, or I should say, what was the other thing? An ability to do what?
To
What?
something like fiberless CDs.
Can be, okay, but it was more importantly an ability to do what? What does water like to do to things? What kind of bonding does it like?
Hydrogen.
Hydrogen bonding, right? Well, will this hydrocarbon-hydrogen bond?
No.
No, because it doesn't have any what?
Of the phone.
Yeah, it doesn't have any FO or N's, right? So, what is Tolman still on here? Either one of the Tolmans on here?
I'm on here right now.
Hey, what was that 5 or less carbon thing we talked about? Do you remember?
It was a little bit ago.
Yeah, but do you remember what it was, what we were talking about?
I'm looking through it in my notes right now.
Because it wasn't, I didn't think it was solubility. Was that the liquid at room temperature? Or I mean a gas at room temperature?
No, it says, it must be less than 6 carbons to be soluble in water and must contain an O or an N.
Oh, okay. That's what it was. So, who are we talking to? Who else was on here that was asking that question?
Me and Jade.
Jade Harlan?
Yeah.
Okay, so Jade, do you see how that doesn't have the FO or an N and it has more than 5 C's?
Yeah,
Does that make sense now?
yeah,
So my question is would that be soluble then?
no.
No, because it doesn't have either of those things. Does that make sense?
Okay. Yeah.
Okay. Now, if it was an organic solvent, like if that was, fingernail polish remover, then it would be. But it wouldn't be in water.
So the 2 drop downs that it's acting are neither.
No, so it says predict the solubility in water, that would be no. Then it says predict the solubility in an organic, that would be yes. Does that make sense?
Yeah.
Okay. Anybody else still on here have a question? Now, I have my Chromebook at home, so if anybody that's still on here needed some extra help, in the evenings you could probably catch me if you were to, we could have like in the individual meets, I could take it over my Chromebook camera up, and I could get my whiteboard out. I got thinking about that, if there was a dire need there. If not, I'll see everybody Monday at 9. Or not Monday at 9, Wednesday at 9, alrighty?
Alright.
Okay, see you guys.
Okay, see you, Denton, thanks.
Yep.